In this lesson, we will introduce functions. So, a function, as you may or may not remember, is a relationship where every input, which we usually refer to as x values, has exactly one output. Which we refer to as our y value. So we'll go over a few examples in just a few minutes. I'm going to introduce two more important vocab words, and those are the domain and the range. So the domain is all possible input values, which I'm just going to say x values. And the range is going to be all possible y values. So let's do some examples. I'm going to ask you which of the following are functions. And actually, I'm going to add something to the directions. I'm going to say if something is a function, we're going to find the domain and the range. So remember, once again, a function has exactly one output for every input, exactly one y value for every x value. So in this case, we have three possible x values. We have 3, 4, and 5 for number 1. And one thing, 3 is okay because it only has 2. 4 is okay because it only has 5. However, 5, when x is 5, y can be both 8 and 9. So this one is not a function. For number 2, we have 4 possible x values, -2, -1, 0, and 1. So when x is -2, we have 5, -1, we have 4. 0, we also have 4, but that's actually okay because even though we have the same y value for two different x's, that's fine because each of those two x's has only one y value. 1, we have 3, so actually this one is a function because every x value has only one corresponding y value with it. And so then our domain and range, remember the domain is the possible values of x, so our only values of x are -2, -1, 0, and 1. The range is the possible values of y. We only have 3 of those. We have 5, 4, and 3. So you don't need to write 4 twice. You can write it as 3, 4, 5 if you want to write them in order. As long as you have them, you're fine. So then for 3 and 4, we are also going to identify if these are functions. So you can do it by thinking about, okay, what are my x values, what are my y values, how many y values do I have with each x value? But an easier way to do it is by using what we call the vertical line test. And that is that if there's anywhere that you can draw a vertical line and hit 2 points, which in this case you cannot, then it's not a function. But since every vertical line we draw only hits 1 point or 0 points, that means that it is a function. So now for number 4, you'll find that at x equals -2, you actually will hit 2 points. If you draw a vertical line there, even though the rest of the graph doesn't hit 2, or anything more than 1, that x equals -2 causes this to be not a function. The reason for that is because when x is -2, we have 2 possible y values. When x is -2, we can either have y equals 1 or y equals 3. So for these next problems, I'm going to ask you, is y a function of x? So this is a fancy way to say, can you write this equation as y equals only one thing? And I'll show you what I mean by that. So what I'm going to do is I'm going to solve for y for both of these equations. And for number 5, it's pretty easy to solve for y. All you do is move over x squared by subtracting it. We get y equals 3 minus x squared. Now, we got this to a form where we got y equals just one thing, which is good. That's what we want. So that means that it is a function of x. And if you don't understand this quite yet, that's okay, because the next one will make it a little bit more clear. So for number 6, we will start by trying to solve for y. That will give us y squared equals 8 plus x squared. We kind of run into a problem when we take the square root of both sides. The reason is because when you take the square root of both sides, you must include a plus or minus. So we will get y equals plus or minus the square root of 8 plus x squared. So that means that when we put a number in for x, for example, if we put in x equals 1, we will get multiple values of y. So for example, if you put in x equals 1, you will end up getting y equals positive or negative 3. That will give us 2 values for y at a certain x value. So you can also think about it as, okay, I can write this as 2 equation. I can write it as positive square root of 8 plus x squared, or I can write it as negative square root of 8 plus x squared. So 2 possible things for y for each x value. And because of that, we say it is not a function. I'm just going to say no. So I'm going to talk a little bit about function notation. I think you've seen this before, but just in case, I'll review it. So usually when you have equations, you will have them written as something like y equals 3 minus 2x. However, if you want to write this using function notation, we can actually give our function an additional name. And in this case, I'm going to refer to it as f. That's our most commonly used function notation. You can use g or h or k or any other letter that you like, but usually we use f. And I am going to rewrite this equation just by writing it as f of x equals 3 minus 2x. So now remember, this is pronounced f of x. So f of x is just kind of a fancy way to write y. It means the function evaluated at x. So let's do some examples. So we're going to use f of x equals negative x squared minus 3x minus 8. And we want to evaluate a few things. So for number 7, what we're going to do is we're going to take our original equation, and everywhere that we see an x, we're going to substitute in negative 3. So we end up getting negative 9 plus 9 minus 8, which is just going to give us negative 8. For number 8 and 9, we also are going to do the same thing. These look harder because they have variables instead of numbers, but actually 8 is really easy. So all you're going to do is everywhere that you see an x in the original equation, you're going to replace it with a t. And that's our answer. So when I give you something like this on the test, I really hope everybody gets it right. That one should be very easy. 9 is a little bit more complicated. You are going to replace every x with an x minus 1. I know it's a little bit weird, but it's just replacing every x with x minus 1. So, of course, you do have to simplify this out. For the stuff in parentheses, remember you're going to use the FOIL method. That's going to give us x squared minus 2x minus 1. Next thing I'm going to do is use the distributive property with my negative and also with my negative 3. So I end up getting negative x squared plus 2x plus 1 minus 3x plus 3 minus 8. So from there, I'm just going to combine all of my like terms. My final answer ends up being negative x squared minus x minus 4.